This is section 12.3, and we are going to talk about the chain rule. Now, the chain rule, if you remember from pre-cal, is when, or college algebra, when you put one function into another. Well, we use that in calculus when we have something like this down here. Our f of x is some function here raised to a power usually bigger than 2, because we don't want to sit here and multiply this out. So there now is a shortcut using the chain rule. And it says that we take the derivative of this thing, just like we've been doing. 8 goes to the front, that exponent becomes a 7. But then we have to multiply it by the derivative of what's inside. So let's think of this down here. Something to the 8th power. The inner layer is x squared plus 5x. So the derivative is this. Take 8 to the front. That becomes a 7 times g prime of x, if this is g of x. And so now we have to multiply by the derivative of this. That's going to be 2x plus 5. So now we have 8 times this to the 7th times this. It's all being multiplied. So sometimes you can just take the 8 and multiply it here. That's this 16x plus 40 times this to the 7th. So either way should work for your answer. Here's another example. Y equals negative 8x to the 4th plus 10x squared, all of that to the 3rd. So y prime, your exponent comes here, 3 times that, you drop one level down on your exponent, times the derivative of this. The derivative of this, 4 times negative 8, that's negative 32, x to the 3rd, plus 2 times 10 is 20x. So it could be that you leave it like this, or you can multiply the 3 times this piece, because it's just to the power of 1. And so you have negative 96x cubed plus 60x times this piece to the 2nd power. All right, now this one is different in that we don't have just a number out here. This is a function of x times this function of x. So we have to recognize that it is a product. So we're going to use the product rule and write our roadmap, and then within that, we may have to use the chain rule. So here's my roadmap. Y prime is first times derivative of the 2nd plus 2nd times derivative of the 1st. So here's the only places that I am taking the derivative. This one requires the chain rule. So I have 4x times 5 goes to the front, 3x plus 5 to the 4th. And then we have to take the derivative of the inside here, which is just 3, plus this times the derivative here is 4. So now I'm going to multiply 5. Oh, here's what I'm doing here. So on this piece here, I've got this times this times this that I can do, and then this piece is raised to the 4th. So I've got 4x times 5 is 20x times 3. So I have 60x times this to the 4th. That's just simplifying. Over here, I couldn't do much. I put the 4 in front, 3x plus 5 to the 5th. Now, if you want to simplify it, and I am not sure, you may be able to leave it like that in math lab. When I do them by hand, I factor out so that I can simplify. And I look and say, what's common on both of these on the outside? I could pull out 4. So I could pull out a 4, and then I could take 3x plus 5 to the 4th out. I can't take the 3x plus 5 to the 5th out of this one. I don't have enough. So this is what I'm factoring out. So what's left when I take 4 out of 60x? That's 15x. And then this out of that leaves 1. So I'm done with that. Now 4 out of 4, that's 1. And if I take 3x plus 5 to the 4th out of this to the 5th, I'm left with one of those. So now I have this on the outside, and when I combine in here, I have 18x plus 5. So you could check and see if this is acceptable, but if not, you may have to clean it up like that. All right, let's go look at our problem sets. All right, so the first problem, they're just asking you to take the derivatives. Y equals negative 5x to the third plus 6x, all of that to the fifth. So with our chain rule, 5 goes to the front, this exponent becomes a 4, and we're multiplying times the derivative here, which is negative 15x squared plus 6. And on this one, I did not multiply the 5 times this, but if it needs it, then you could just say 5 times that is negative 75x squared plus 30, and you could do that. But I think maybe on this one, I found that it would let you. I usually work all your questions. So on this one, number 2, same idea. We're going to say negative 6 times negative 5 is 30 times this. Now take 1 away, so that's a negative 7 times derivative here is 6x. I did multiply the 30 times the 6x here, put that and that to the negative 7. So one thing you can do if you're not sure about the format, when you go to your math lab problem, there is a place where you can ask for show me an example, and it will, and just go through continue till you get to the end of the problem, and you can tell the format that they have it in. If they leave it like this, then you're good to go. If not, then you may need to do this, but you could check that out. All right, number 3, you are given 8 times the square root of 3x squared plus 5. Now I put this thing in parentheses, and I put an understood 1 here. If there's not a root, an index here, it's always understood to be 2. Square root is a 1 here and a 2 here. So we switch this radical to fractional exponent. So this is 8 times 3x squared plus 5 raised to the 1/2. This is always your numerator. This will be your denominator. Then you can use the chain rule. 1/2 times 8 is 4 times this. Now take 1 away from a half and you get negative 1/2 times derivative of this is 6x. I went ahead and multiplied the 4 times the 6x, and I have this. Now, if I don't want negative exponents in my answer, which I didn't have any here, I want to put this piece on the bottom. So that's what this step is. That's the same as 24x over 3x squared plus 5 to the positive 1/2. Since the original right here was in radical form, I put it back in radical form. That's most often what they want as far as their answers. So that thing went back in the radical just like it was there. So that's number 3. Number 4 looks a bit involved. What it is 2 functions, and it's a product. And so the very first thing, we're going to use the product rule. We're going to write our roadmap. This is a 3. I don't know if I can do that with my mouse, but let's see. There we go. And this is a negative 2. So we'll get rid of that thing. Okay, so we're good. All right, so y prime is the first times the derivative of the second plus the second times derivative of the first. Not doing anything there except writing out your roadmap. Now you know the only place you find derivatives are where it's yellow. So first times, negative 2 goes to the front. That becomes negative 3. The derivative of this inside is 2. Plus this whole thing times 3 comes to the front. This exponent becomes a 2. And the derivative inside is 3. So in that line, all I did was take these 2 derivatives. Now I'm going to clean it up a little bit. So this 2 can multiply by this negative 2. And I have 3x plus 4 to the third times negative 4 times this to the negative third. Plus, I'm going to multiply the 3 times the 3, get 9 here. So now I've got this. And you have a lot of the same things, and you want to factor this out to clean it up. So you're saying, I've got a 3x plus 4 in both pieces. I've got a 2x plus 5 in both pieces. Remember that you always want to factor out the smaller of those. So the 3x plus 4, I have 1 to the third and 1 to the second. So I'm going to factor out the 1 to the second. In 2x plus 5, I have 1 to the negative 3, 1 to the negative 2. The negative 3 is smaller, so I take that out. All right, now when I take this much out of here, I am left with one of these. So I'm left with 3x plus 4, and I'm left with a negative 4, and then this comes out, so that's canceled out. Over on the second one, when I pull out a 2x plus 5 to the negative 3, when you're dividing that out, you want to think that's, you subtract the exponents. So negative 2 minus a negative 3 becomes negative 2 plus 3. So you end up with a 2x plus 5 to the first. Okay? Maybe I need to write that out for you. Okay, I have added that over here. So you're saying out of this, you're dividing 2x plus 5 to the negative 3. And so it's negative 2 minus a negative 3. Well, that becomes negative 2 plus 3, which gives you a positive 1. So it's 2x plus 5. That's what you've got here. Now in the next step, I'm going to clean this up in here. So negative 4 times this is negative 12x minus 16. 9 times this is 18x plus 45. I'm going to clean it out one more time, clean it up one more time, and I've got 6x plus 29 times this on the outside. This is what I factored out. Now, why is this highlighted? Because it's a negative exponent. It needs to go to the bottom. So I'm left with 3x plus 4 squared times 6x plus 29 all over 2x plus 5 to the positive 3. And that would be your final answer on that one. All right, let's look at number 5. Number 5, we're going to do a rewrite on this. When you see this on the bottom, we need everything to be on the top, one line. So if it moves to the top, this changes from a positive exponent to a negative exponent. We have 6x minus 7 to the negative 8. Then we can use our chain rule. Negative 8 comes to the front. That negative 8 becomes a negative 9 times the derivative of the inside, which is 6. So 6 times negative 8 is negative 48 times that to the negative 9. Because we want to lose the negative exponent, it goes to the bottom and the exponent becomes positive. So that is your answer there. Okay, number 6, you are given f of x is equal to 5x times x squared minus 4x plus 5 to the 7th. And we want to find the derivative at x equals 2. And find the equation of the tangent line. All right, so the point that we're talking about at x equals 2, how do I know what the y part is? If I plug in 2, I need to find f of 2. That means put 2 for every x. I do all of that, I get the number 10. So you're just plugging in 2 for x here, here, and here, and raise that to the 7th, and you get 10. All right, now, so we have a point, 2 comma 10. That's my x1, that's my y1. To write the equation of the tangent line, now that was just to give us a point. That wasn't any calculus. That was just algebra. So you can do this. Remember, we have that mathematical numerical derivative. If we bring our calculator up here and you hit Math 8, and your function is this, variable is x and 2. So if we did that here, we would have an x there, And then here we would have another parentheses, 5x times a parenthesis, x squared minus 4x plus 5, close, to the, we'll raise it with a caret, 7th, and I think we're good. Let's see. Let me see if I've got the right number of parentheses. So I think I may have had an extra one here, because you always have to have one to close when you open. So this one opens, that closes that, open, close. I think I had an extra one. And then at x equals, I've got to go all the way over. Oops, back. At x equals 2. All right, and then we'll hit enter, and we get 5. That's essentially 5. And if you, so that's what we did here. I wrote the old way. If you have an older calculator, you'll have to hit Math 8, you'll get in deriv, and then you can put this in and comma x, comma 2, if you don't have the icon. So now we have, let me get rid of that. Now we have the slope when x is 2, and we have the point 2 comma 10. So we have x1, y1, and m. We're going to use the point slope form, and we're going to fill in what we know. So it's y minus 10 equals 5 times x minus 2. Go ahead and distribute that, and then add 10 over here. You end up with y equals 5x. That is the equation of the tangent line when x is 2 in your original function. The last one is a word problem, and I think it was not in the original problem set. So, but this is what you'll see in your homework. So, to test an individual's use of a certain mineral, a researcher injects a small amount of a radioactive form of that mineral in the bloodstream. The mineral remaining in the bloodstream is measured each day for several days. Suppose the amount of the mineral remaining in milligrams per cubic centimeters T days after the initial injection is approximated by. So here is our function. That says how much is going to be there for T days, at T days. Find the rate of change of the mineral level with respect to time for 7.5 days. 7.5. All right, so we've got, and I changed this, if we want to do this on Math 8, which you're able to do, change that to 0.5, change that to negative 0.5. So here is my function. So Math 8 in deriv, here is the function, comma x, comma, why did I use 0? I don't know. Let me check on that. Okay, I think the problem must have 0 days in the sample that I had because I looked at another one. So whatever number is actually in your problem, whatever days, will go here. That's the x equals. And so for this one, it came out to be negative 0.19 was the rate of change of the mineral level for 0 days. So whatever number you're given in this part of your problem is the number you're evaluating Math 8 at. And so remember, when you're in your calculator, that's the number that goes right there. So if you hit Math and 8, if you have the newer one, that number, whatever it is, goes there. Your function goes here, x goes here, and here. If you have the older calculator, you're going to hit it and you'll get this in deriv. You put the function, comma x, comma the number. And that should get you going on 12.3.